In this video, we're going to be doing the second part of using the z-table. Most standard normal distribution tables have a diagram. This particular diagram, you'll note, is shaded from the center to the right. If you have a diagram like this for your table, then I would recommend you watch the previous video. In this video, we're going to use a z-table that the shade starts from the left and it goes to the right. So you're going to need this diagram for your z-table. And usually your z-table has 2 pages. The first thing I want to do is to shade the z-curve and show you how that corresponds to the table. Okay, first of all, the table has a minimum value of negative 3.09. Of course, that's a z-score. And a maximum of positive 3.09. Okay, so I'm going to shade the z-curve this way, from negative 3.09 to negative 2. Now I shade from the left to the right because our diagram that's attached to our z-table also shades starting from the left to the right. Okay, so I have this shaded area in red. How does that correspond to the table? It corresponds to this part of the table. I'm going to show you a little bit later on how to read the table, but this red area has a probability of 0.0228 or 2.3%. What about if I shade this piece, the orange piece, from negative 2 to negative 1? That corresponds to this part of the table. And if we wanted to know the probability between negative 3.09 to negative 1, it's approximately 16%. So you see that the farther we go to the right of negative 3.09, the larger your probability. And if I shade in the green part on the z-curve from negative 1 to 0, it corresponds to this part of the table. Now we have half shaded, so you expect the probability to be 0.5. Not exactly, but close enough. Now let's do the second half of the z-table, and we know that half is shaded. Probability is 0.5. Now let's shade from 0 to 1, which is the blue area. That corresponds to this part of the table and has a probability from negative 3.09 to 1 of almost 84%. And then shade the purple from 1 to 2, and that corresponds to this part of the table, and the probability between negative 3.09 to 2, all that corresponds to about 97% of the table, maybe 98%. All right, and then the yellow from 2 all the way to 3.09, that piece corresponds to that in the table. And from negative 3.09 all the way to 3.09, the area is going to be 0.9990. Not quite 1, but very close to 1. Now the exciting part, how to read the table. So let's say we have a z-value of 1.47. To read the table, we're going to have an understanding of something called place value. How do we do that? Well, one way is to do an analogy. Let's say 1.47 is $1.47, okay? And in $1.47, the $1 is in the ones place, the 4 is in the tens place, and the 7 is in the hundreds place. The ones, the place value of the ones, you can change that to $1, $2, $3. You can even put negative 1, negative 2. In the tens place, you have 40 cents. You can have 50 cents, 60 cents, 70 cents, and so forth. In the 7 and the hundreds place, you can have 8 cents, 9 cents, and so forth. So you have to understand the hundreds place, tens place, and one place in the table. So where's the hundreds place, right? Where's the cents place in the table for the z value? It's right here. You can see that you have 6 cents, 3 cents, 1 cent, and so forth. And for the ones and the tens, it's in this column. You can see that you have things like 40 cents or $1.80 or something like $2.70. Okay, now we're ready for the z-score of 1.47. Think of it as $1.47. So first piece is the ones and tens, $1.40. Where's $1.40 in the ones and tens column? Let's look. That's right, there it is, $1.40. We draw a line going across. And now we look for the hundreds place, 7 cents. We look at the top, 1 cent, 2 cent, 3 cent. Where's 7 cents? Right there. Okay. Where do they cross? Right there at 0.9292. Note that, and this is very important, that the probability of a z-score of 1.47 is not 0.9292. Okay. Remember that probability for a z-table, we need a range. Okay, and we'll see that in an example that we'll have in a little bit. Okay, but if we're looking for a z-score of 1.47, boom, that's the answer, 0.9292, and you'll see how we use it in a minute. Okay, now let's try a z-score of negative 1.53. Think of it again as negative $1.53. So we're going to focus on the left side of the table. We have the hundreds place, 1 cent, 2 cents, 6 cents, and so forth. And then the ones and tens column, right? Which you can see is negative $2.10, negative $1.60, and so forth. Why are we focusing on the left side of the table? Because that's where the negative z-scores are going to be located at. So in our case of a z-score of negative 1.53, think of negative $1.50 first. Where's negative $1.50 in the ones and tens column? That's right, it's right here. And now, where is the 3 cents? Look on the top, 3 cents for the hundreds place. That's right, it's there. And then where do they cross? Right, at 0.0630. And now we're ready for some examples. So I'm going to do the probability of z is greater than 2.87. And what I want to do is I want to create a standard normal. And that's going to help me understand the table better. So let's draw the standard normal with a population mean of 0 and a population standard deviation of 1. Okay, let's look for 2.87. Where's that located in our standard normal curve? Well, it's going to be to the right of 0. So, okay, let me write it down, 2.87. And the next thing I want to know is, how am I going to shade this? Am I going to shade to the left of 2.87 or to the right of 2.87? Well, it says z is greater than 2.87. Z is bigger than 2.87. So bigger means to the right usually. So we're going to shade to the right of what? 2.87. So I'm going to shade, and there it is in orange. Now, keep in mind, that orange shade, do you think that's a 50% of the curve? No, not at all. It's less than 50%. Okay, let's keep that in mind, because when we read things on the table, we think, well, that's the answer. Well, we got to be more careful. Okay, so the next thing we want to do is let's find 2.87 on the table. Again, 2.87, think of it as $2.87. So the ones and tens place, that's going to be $2.80. Where's the ones and tens column for the Z? Right there. So let's look for $2.80 right there. We'll draw a line. Okay, now let's look for the row for the Z's for the hundreds place. Okay, right there. We're thinking of 7 cents, 7 cents right there. We draw a line, boom. Okay, now that crosses right there at 0.9979. Do you think 0.9979 is the area of the orange? No, of course not. 0.9979 is the area that is from negative 3.09 all the way out to 0.287. So that doesn't give us the answer, but it's going to help us. So the orange spot, how are we going to calculate that? Well, it turns out that negative 3.09 all the way out is 1. Of course, if we shade the whole thing. So to find the orange area, what we're going to do is we're going to take 0.9979 and subtract that from 1. We do the math, and we get 0.002. That is going to be our probability. So the probability of Z being greater than 2.87 is going to be equal to 0.002, which, by the way, is the same answer from the previous video when we had only one cumulative table that goes from 0 to 3. So the next problem states, what's the probability between 0 and 1.36? Okay, let's draw a standard normal curve. And let's shade between 0 and 1.36. Okay, we got the 0. 1.36 is going to be what? To the right of 0. Okay, here it is. And then we need to shade between 0 and 1.36. Okay, we got it. Now let's think. Okay, the orange shade, we know that that's not bigger than 50%. It's not even close to 50%. So we're going to keep that in mind. So 1.36, we got to find that on the table. So the analogy is that that's $1.36. So the first thing we want to know is, where's $1.30, right? So we look at the Z column for the ones and tens, look for $1.30. Where is it? Right there. Okay, then 6 cents, right? The hundreds place, we look on the top, and 6, there it is. So that's telling us that 1.36 or $1.36 gives us an area of 0.9131. So 91.31%. That is not the answer for the orange. We know that. So what does that 0.9131 tell us? Well, that tells us that if we were shading from negative 3.09 all the way out to 1.36, that would be an area of 0.9131, which is not the answer that we want. So how are we going to find the orange piece? Well, it turns out that this blank piece on the left of the orange, that's going to be what? Half. That's 0.5. So if we subtract 0.5 from 0.9131, it's going to give us the orange piece. And that's what we're doing here. And there it is. So the answer is 0.4131. So the probability of Z being between 0 and 1.36 is going to be 0.4131, which is, by the way, the same answer if we were using one cumulative table that goes from 0 to 3. All right, let's do the next example. What's the probability that Z is between negative 2.01 and negative 1.21? So we draw the standard normal, and okay, where is negative 2.01? That's going to be on the left of 0. Let's say it's over here. And where is negative 1.21? Well, it's not on the left of negative 2.01, but it is on the left of 0, so we're going to write it here. Okay, and then we're going to shade. So we're going to shade between negative 2.01 and 1.21. There it is. Okay. And now, the next thing we want to do is, let's find the z-score for negative 2.01 on the table. Again, negative 2.01, that's a negative value. We're going to be using the left table because it has the negative z values. Think of it again as negative $2.01. So let's look for $2 on our z table. Again, $2 meaning the ones place. And where's that? Right there. Okay. So that's the $2 area. And then let's look for what? 1 cent. Where's 1 cent? Right there. So where does it cross? At 0.0222. Okay. So what is that 0.0222? Tell me. It tells me that that's the area that goes from negative 3.09 all the way up to negative 2.01, which is not the answer that I want. Okay. All right, so we got to keep on going. We have another z-score value of negative 1.21. Same idea. Think of it as negative $1.21. So $1.20, where's that at? Right there. Okay. And 1 cent, one more time, where's that? Right there. Where's it cross? Right there at 0.1131 or 11.31%. So what does that tell me? Well, if the shade went from negative 3.09 all the way up to negative 1.21, that would be the area, 0.1131. But these two answers, these two probabilities, we have to figure out what do we need to do to figure out the orange piece? Well, it turns out that if we subtract 0.0222 from 0.1131, we would get the answer, and that's going to be 0.0909. Okay, now that's going to be our probability that the probability that z is between negative 2.01 through negative 1.21. Okay, let's move on to the next one. What's the probability that z is between negative 0.16 and 1.23? Okay, let's draw it one more time. Our standard normal curve, and we get negative 0.16. Where's that at? Well, that's going to be to the left of 0. Let's say it's over here. And 1.23, that's going to be to the right of 0. Let's say it's over here. All right, so that's the area that we want to shade. And let's look up in the z table, negative 0.16. That's going to be on the left table. Negative 0.16, right? So that's, think of it as money, 16 cents. So first we look for 10 cents. Or, yeah, and remember, we're looking for 10 cents in the ones and tens column, okay? Where is that? Right down here, okay? So what about 6, right? That's going to be the 6 cents that we want. We look on the top, 6 cents, there it is. And where does it cross? At 0.4364. Okay, that area, it goes again from negative 3.09 all the way out to negative 0.16, which is not the answer that we're looking for. Okay, now let's look for the z-score of 1.23 on the table. So that's $1.23. So think of $1.20. Let's look at $1.20. Where's $1.20 on our column here? And there it is. And 3 cents. Let's look for 3 cents. There it is. And where's that hit? At 0.8907. That number tells us that the probability of 0.8907 started from negative 3.09 all the way out to 1.23. Of course, that's not the answer too, because that shade doesn't look like 89%. So what do we need to do here in this situation? Well, it seems like if we take away 0.4364 from 0.8907, we'll get the answer that we want. And that's what we're doing here. And we get an answer of 0.4543. So the probability that z is between negative 0.16 and 1.23 is going to be 0.4543. And that's, again, the same answer as if we would use a cumulative table from 0 to 3, which is pretty amazing.